Hi, in this video we're going to working on page 313, problem 2, and then page 314, problem 3. Alright, so we are continuing to use rational root theorem, what we learned yesterday. What are the rational roots of 15x cubed minus 32x squared plus 3x plus 2 equals 0? So we have to list all the possible rational zeros. What should we find out? You have to find the factors of constant and then factors of leading coefficient. Okay, so you have to write that down as a reduced form. And those are the possible rational roots, which is plus or negative 1, plus or negative 2, plus or negative 1/3, plus or negative 2/3, plus or negative 1/5, plus or negative 2/5, plus or negative 1/15, plus or negative 2/15. So you are having total 2, 4, 6, 8, 10, 12, 14, 16 possible rational roots. Now, we are going to test each possible rational root until you find the root. I told you that steps are going to take for a while. And, I will starting with x equal 1. So if I use x equal 1, I have to plug it into my given equation, which is 15, 1 cubed minus 32, 1 squared plus 3 times 1 plus 2. The key is you have to check it out. That will give you 0 or not. If it's not 0, then that's not your root. So 15 minus 32 plus 3 plus 2. Even if you don't really calculate fully, you know that that's not going to be 0. So 1 does not work this time. What about x equal 2 this time? So 15, 2 cubed minus 32, 2 squared plus 3 times 2 plus 2. 15 times 8 minus 32 times 4 plus 6 plus 2. 15 times 8, that will be 120. Minus 128 plus 8, okay, that will be 0. Oh, I found out my answer, which is x equal 2. So now, you're going to keep factoring the polynomial by using this number 2, by using synthetic division. So I would do 15, negative 32, 3, 2, and using what number? 2 this time. So bring 15 down, multiply 2 and 15. There will be 30. Write it down. That should be added every single time. That will give you negative 2. Now what? 2 times negative 2 become negative 4. There will be negative 1. Negative 1 times 2 is negative 2. Please put it down under here. Okay? So I would rewrite my equation as 15x cubed minus 32x squared plus 3x plus 2 would be product of x minus 2 and my quotient 15x squared minus 2x minus 1. If the second one can be factored out, please keep doing so that you can find your roots easier. If it's not going to factor out, you have a powerful way to get your answer, which is quadratic formula, right? So if they're not, these numbers are rational roots, then you cannot take it. But let's work it on 15x squared minus 2x minus 1. So product of 15 and negative 1, that would be negative 15. And I have negative 2. Which two numbers to make a negative 15 by multiplying and negative 2 by adding? So it seems like 3 and 5 will make a 15 and then they are 2 apart. 5 and 3, but I have a negative 2. 5 should have negative sign. So now what? I can rewrite my expression as 15x squared minus 5x plus 3x minus 1. Keep going. X minus 2. And there will be, you can grouping it, which is 5x, x minus, or 3x minus 1, and then you have 3x minus 1 here, which is x minus 2, 3x minus 1, and 5x plus 1. So now I'm done with factoring. Now how can I get my roots? You have to set up all of them are at 0. It can be 0. It can be 0. It can be 0. So my one answer, x equal 2. The other answer, x equal 1/3. And the other x equal negative 1/5. So those are my rational roots. Alright, so I'm going to give you time to work on Got 2 by yourself. So please pause this video, and after you solve it, please check the answer. Alright, Got 2. What are the rational roots of 2x cubed plus x squared minus 7x minus 6 equals 0? Okay, so please list all the possible rational roots, which is factors of constant, which is 1, 2, 3, and 6. So list the factors for constant, and then factors of leading coefficient, which is plus or negative 1, plus or negative 2. Now write down as a simplest form. There will be plus or negative 1, plus or negative 2, plus or negative 3, plus or negative 6. You are going to have a duplicate answer. Please drop that off. So 1/2, which is plus or negative half, plus or negative 2/2, that will be plus or negative 1. You already got it. Just skip. And you're having 3/2. And then 6/2 becomes 3, so you don't have to write that down. So that's it. Now, next step is test each possible rational root until you find the right one, which is making your entire equation at 0. So let's check it with the numbers. So it's totally up to you how to choose it, but I prefer to choose 1 or negative 1, starting with that. So I'm going to start with my 1 this time and then check it out how it's work. So replace x as a 1, and you got this, and then 2 plus 1 minus 7 minus 6. Okay, even if I don't really calculate fully, it does not give you 0. What about x equal negative 1? Let's try with that. So 2 times negative 1 cubed plus negative 1 squared minus 7 times negative 1 minus 6. So this one, I got negative 2, because negative 1 cubed become negative 1. And then I have positive 1, I have positive 6, and minus 6. Okay, 1 plus 7 becomes 8, and negative 2 and negative 6, there will be negative 8. Oh, okay, there will be 0, which is, I can use my negative 1 to the factor this one fully, so that I am able to find the rest. So set up the synthetic division. Pull out all the coefficients. 2, 1, negative 7, and negative 6. Put upside down division symbol. And I'm using negative 1 this time. Now what do? Bring 2 down. Multiply them. It should be right down here. Add them up every single time. 1, negative 6, and positive 6 equal 0. So as we talked about before, your 0 would be remainder. So I have to pay attention for those 3 numbers. What is it? That is a quotient. So my quotient this time is 2x squared minus x minus 6. So let me rewrite it as which is x plus 1 and 2x squared minus x minus 6. All right. Now what do I need to do? You have to factor out fully. So 2x squared minus x minus 6. So product of 2 and negative 6 would be negative 12, and I need to make negative 1. Okay, so two numbers to make a 12, 3 and 4, but they are having negative 1 as a sum. I have to have a negative in front of it, in front of 4. So now what? You're going to write it down as of like this. Okay, now grouping so that you can factor fully. So x would be your common factor, so you can get this, and you can pull the negative 2 out. You can make a 2x plus 3 here. So x plus 1, and take it out your common factor, 2x plus 3, and you can finish up the factoring like this. Alright, so by applying zero product property, that I can get my answer like this. So my first answer would be x equal negative 1. My second answer, x equal negative 3 over 2. And my last answer would be 2. Okay? So the key is you have to find out one rational root so that you are able to factor fully, and that will be much easier. Alright? Okay, let's move on to the page 314. So we are going to look at the theorem, which is a conjugate root theorem. So, lesson 4-8, that you learn the complex number a plus bi and then a minus bi are conjugate. Samely, if you have an irrational number, which is a plus radical b, you can find a conjugate, which is the same number and the opposite sign. Okay, so if p of x is a polynomial with real coefficient, then the complex then you are going to have a complex root, which is a plus bi and a minus bi. If p of x is a polynomial with rational coefficient, then you are going to expect that you're going to have a plus radical b and a minus radical b. Okay, so let's working on the page 314, problem 3. Using the conjugate root theorem to identify roots. A quartic polynomial p of x has a rational coefficient. Okay, so according to the conjugate root theorem, you're having rational coefficient. You can expect that you're going to have if you have a form a plus radical b, then you would have a minus radical b as another root. So if radical 2 and 1 plus I are the roots of p of x equals 0, what are the two other roots? Okay, so I have a radical 2, which is my conjugate of radical 2 would be what? Negative radical 2. And then find the conjugate of 1 plus I, which is 1 and minus I. That is happened because of the conjugate root theorem. Okay, so since p of x has a rational coefficient, and then a radical 2 is a root of p of x, so follows from the conjugate root theorem, you can say negative radical 2 is also a root. Since p of x has a real coefficient and a 1 plus I is a root of p of x, so that 1 minus I would be another root for this question. Alright, so I'm going to give you time to work on Got It 3 by yourself. And if you complete Got It 3, please resume the video to check your answer. Alright, Got It 3. A cubic polynomial p of x has a real coefficient if 3 minus 2i and 5 over 2 are two roots of p of x equals 0. What is one additional root? So think about it. I have two answers presented, which is 3 minus 2y and 5 over 2. Is 5 over 2 irrational number or complex number? What do you think? 5 over 2 is a rational number. So we don't have a conjugate root, which is 3 minus 2i should have a conjugate root. The direction says already, the question says already that you are having one additional root. Even if I don't give it to you, you should know it that you are going to have only one, which is 3 minus 2i. So what is the conjugate of 3 minus 2i? 3 plus 2i would be another additional root. Okay? Alright, I hope this video helps you. Thank you.